Okay, so that right away I'm thinking I need to change 4. So change side 4, or I mean, sure, the side with length 4. And then since the new triangle is isosceles, it has to change into 5 or 6, because whatever number you change has to change into an already existing number. So right now, the only one that makes sense would have to be changing 4 to 6, because we want the biggest number possible, right? So if we do 6, 5, and 6, that gives me perimeter 17. And I'm trying to think right now, is there a better way to do this? Can I get higher than 17 in any way, shape, or form? I don't think so, right? Because
Yeah.
I mean, we already took the smallest side. Because if we took 6, for example, we'd have to decrease the length. Which means, yeah, I think this makes sense.
Yeah, that makes sense.
Okay, let's see what you guys are saying in chat.
Yeah, and I think like you might also want to check that it's a real triangle. Like obviously it is, because 6, 6, and 5 is so similar to the equilateral 6, 6, and 6 that it will probably be a real triangle. But if you had something like 1, 1, and 3, then that would just not make sense. So yeah, some of you guys were talking about triangle inequality. That's also useful for problems like this. Yeah. Oh,
Yeah,
2,
that's a
3,
great
4,
point, though.
5. Wait, 2, 3, 4, 5. That's an interesting thought. I think it might be 5, 5, and 6 that you're talking about. But like, yeah, if you take 2, 3, 4, 5, let's just do this for fun. And then you put them
I see.
together. Yeah, so that's an interesting thought. It would definitely work for like 6, 5, 5. But yeah.
That's interesting. But yeah, the point about the triangle inequality is great,
Yeah.
because you always want to think about triangle inequality. You never know when a triangle that doesn't exist
Yeah.
might sneak
Oh,
up
by
on
the
you.
way, the triangle inequality, just to like write it down, it's that
Of
if you
course.
have a triangle with side lengths A, B, and C, then you must have A plus B is greater than C, and the same thing for the other two. So like A plus C is greater than B, and B plus C is greater than A. And like these 3 things, like they're obviously true, because if you try to make that not the case, then you would end up with like a line or something that obviously can't be a triangle. So yeah, it makes sense in your head.
I kind of have it over here. Basically,
nice.
If the third length is too long, you can't stretch out A and B so that it matches. It makes a triangle with the third length, so that always have to work. Awesome. All right. I think that's it for this problem, right?
Cool.
Professor?
Yeah, I think so too.
Okay.
I guess I take over the next one. What is this?
Okay.
Oh, okay. So now I have to read. Everyone able to see me? I think so. Yeah. Now I have to read number 13. Let x, y, a, and b be real numbers such that x plus 2y is a and 2x plus 3y is b. Then y minus x equals m times a minus n times b, where m and n are positive integers. What's the value of m plus n? Okay, well, when I see something like this, I'm like, can I just make a y minus x? There's all these letters here, all these letters. So I guess I'm just interested in trying to find a way to make a y minus an x from an x plus 2y and a 2x plus 3y. Interesting. I guess I could solve for x and y. I'm just wondering if there's a nicer way than that. Because, oh, well, I actually see a very ad hoc way. Maybe my co-host will see a better way to do this. But I'm just like, I just see a way I can get rid of the x, because I see that if x plus 2y is a, then 2x plus 4y is equal to 2a. And I already knew that 2x plus 3y was equal to b. Okay, elimination. Yes, I see in the chat, people are talking about this. This is elimination. See, at first I was wondering if I could just do a really quick trick, like take this minus that or something. Maybe you can, but I'm not fast enough to see that. But here I'm just going to eliminate the x by subtracting these 2 equations. If you subtract them, I get that y is equal to 2a minus b. Okay, well, in that case, if I know what y is, I guess I can just figure out what x is, because x plus 2 of the y's is that a. So that means that if x plus 2 of the y's is 4a minus 2b, that's equal to a. So then, oh, Vivian, did you say something? Did I make a mistake already?
No, I didn't say anything. So
okay.
Go on.
I'm liable to make a mistake. Also, I'm very scared whenever I write a B, it looks like a 6. I've done so many math contests where I write that thing and I think it's a 6. And it's like,
no.
But now I just subtract y minus x. All right. So if I take y minus x, that puts everything together. I have 2a minus negative 3a's, that's 5a's. And then minus b, but plus 2b becomes plus b. Okay. Did I do that right? Y minus x. Always these things I'm trying to double check, make sure I didn't make some mistake. Seems okay. All right. So in that case, y minus x is ma's. So m is 5. And minus n. Whoa. What a strange thing. Now I'm scared. I wonder if this is even right. So I'm getting that m equals 5. And minus n was 1. So n is minus 1. And so putting all this thing together, I'm getting 5 minus 1 is 4. Is that right? I'm scared. Let's see. So I think it's just 4.
I mean, we could always check it.
Uh-oh, chat is
Oh!
saying negative 3a
I did
plus
it
2b.
That happens. Okay, help. Co-hosts, where did I go wrong?
Okay, let's see. So,
I've been trying to figure it out myself. So
Wait a
Let's see.
second. What's going on? The answer is 8.
okay.
Oh,
So
no.
the first part is
Yeah,
definitely
make mistakes, but
right.
it's totally cool. Totally cool. You can. Where's the mistake? Everyone, help, help, help. Oh, minus 2b to plus 2b. Is that what happened? Y minus x.
Oh, when you attribute
Oh
both
yeah, it
sides.
should be that.
That's
Great
right.
catch, guys.
Wow.
Oh, there it is. And that's why there's this. That's why there's this mistake of 4, right? So that also makes
Wow.
sense, because then y minus x. Now you get minus 3. Oh man, you see, this is why I have co-hosts here, because they do a better job. So far,
Wow.
we made the mistake. So that's the n so it's minus n, right? So the reason I was a little bit worried is I was like, why negative n is positive 1? But so now I get n equals 3. And I'll leave the 4 there because that was wrong. That's the shame. It's actually 8. All right.
Okay.
That's that.
Yeah,
Yeah.
these types of problems are really easy to screw up. And also, like, since there are so many variables, well, a good thing to do would just be to like kind of erase m and n from that picture and just think about it as like y minus x is something times a minus something else times b, and you want to find those something and something else. So like m and n are basically irrelevant to the entire problem. All you really have to look at is x and y, and then finding them in terms of a and b and vice versa.
Yep.
Yeah.
And Professor Lowe, earlier you asked, like, is there like a more efficient way to do the problem? I didn't necessarily come up with like a faster way, but I did in a way where you don't have to solve for x and y.
Oh, okay. I was
So-
hoping there was one of those. Eddie, what is it?
Right. So
Oh, yeah.
looking at the problem, what we can see is that
Oh, yeah.
we're looking for y minus x. So this is my logic, how I thought through it. So y minus x, well, the coefficient of y is 1 and the coefficient of x is negative 1, right? So the difference is 2. They're like 2 off if you think about it. But in this equation, for example, the coefficient of x is 1, but the y is 2. So the difference is only 1. So what if I double that equation? Now I double the equation to put the y before the x because we're looking for y minus x. And now I have it so that the coefficient of y is exactly 2 more than x. And so now all I have to do to get to the end goal is y minus x, right? The end goal is to get y minus x equals something. I just need to subtract 3x plus y's away from that. Well, the two equations that we started off with perfectly give us x plus y.
Nice.
And then now that we have that, all we have to do is subtract 3 times b minus a from this. So you get minus 3, oops, here, I'll do it in white, minus 3b minus a. And then in total, you'll get, wait, did I do this wrong? Hold up. It looks right, right?
You're good. You're good. You're good.
Okay.
You get the right answer.
Okay, and then
I
you
think.
get 5. Wait, yeah. So that's why I paused for a moment. So this is what? 5a
Yes, you get your 5.
minus 3b.
Because yeah,
Wait,
Right.
what's the answer? I forgot what the answer was.
it's 5 plus 3 is the answer. You got it.
Oh, it is. Okay, cool. I didn't realize I had the right answer. Okay.
Yeah, yeah, yeah.
Awesome.
Awesome. Okay. Well, thank you. Thank you.
Awesome.
Let's keep going. Vivian,
Oh
I think.
yeah, wait, okay. I tried to do it too, and basically I just added the two equations and got x. Well, no, I subtracted them and got x plus y equals b minus 3a, and then I added them and got 3x plus 5y equals a plus b, and then multiplied this x plus y by 4 to get the 4x plus 4y, and then did 3x plus 5y minus 4x plus 4y and got y minus x.
Oh,
There's many ways of doing it.
Yeah.
Yeah, anyway.
I think that's the coolest one. Awesome.
Okay. Yeah, there's many
Let's
interesting
go on.
ways.
Vivian, you're up next.
Oh yeah, okay. Let's see what problem next. Oh my gosh, why do I always get like the paragraph? Another paragraph. Okay. This one's like really a paragraph. So 30 students in the
Oh, no.
class. Wait, let me make this like a tiny bit smaller. Okay, there. Hopefully you guys can still read it. So 30 students in the class. Each student who has quarantine has to stay home for the rest of the week. Okay, and if they're not quarantined, they attend class. Okay, so each day they divide the students into pairs. Okay, so the 30 students get divided into 15 pairs every day. I see. And if you get to the point where there are 3, oh, okay, so the students who are in pairs have to be like the students who don't have COVID or aren't quarantined, because like the students in pairs are the ones in the classroom. Okay, I see. So if you get to the point where there are 3 students remaining in the classroom, then there's one triplet. Okay. So let me just write this out quickly. So pairs of present students, and then 3 left makes a triplet. Okay. So there's full attendance on Monday, which means that no students are in quarantine. So on Monday, 0 gone. Okay, what next? Starting Tuesday, 3 students get quarantined. Okay. Oh, so we're just counting like how many days of the week there have to be a triplet. Oh, okay, wait, I see. Okay, Meek, sorry, I don't know if I'm pronouncing your name right, but Meek, you're saying that as long as there's an odd total number of students, you have to form a triplet. So let's write this down because that's really important. So odd number of students implies that there's a triplet. Is this true? Well, obviously, like if there's an odd number of students, then you can't pair them up, because if you try pairing them up like this, there's going to be one left over since it's odd. So like, yeah, since it's impossible to do it with pairs, there obviously must be a triplet when there's an odd number of students. So that makes sense. What about if there's not an odd number of students? What about if there's an even number of students? Then if there's an even number of students, then does there have to be a triplet? Well, I don't think so, because even number of students means that they can just get paired up, like Kevin is saying, or Kevin, sorry. So even number of students means no triplet. Okay, so we basically just want to find, since we want to find on how many days of the week is there a triplet, we just want to find how many days of a week, how many days over the week are there an odd number of students. Like this is all we care about, whether the number of students is odd or even. And I think this problem is now a lot simpler. Let's write down for every day how many students are there. So starting with Monday. On Monday, there should be 30 students there because none of them are gone, right? On Tuesday, it says that there were 3 students who got quarantined, which means that the 3 students are now subtracted from 30, so there are only 27 here. And you guys are already jumping to the answer. I see all of you guys know the answer already. That's great. And then on Wednesday, 5 more are gone, so 27 minus 5 is 22. On Thursday, I guess I'll write H. How many students? 6 more students get quarantined. So 22 minus 6 is 16. And finally, on Friday, 7 of them are gone. So 16 minus 7 is 9. Okay, now all we need to look at is how many of them are odd, right? Because odd means triplet. Odd is equivalent to triplet. So I think that would just be this one and this one, right? So I guess it's 2. That problem.
I hope that's right. I think that's right.
Yeah,
it looked way more complicated than it actually is.
That was a really long problem just to ask if
I know
a number is even or odd.
I know, exactly.
All right.
Let's see. Is that right?
Yeah, I believe it's 2.
Okay.
Let's see.
By the way, I just want to jut in because I know some people joined a bit late in this live stream. If you're wondering how everyone's able to talk, you type to chat relay. So
Yeah.
again, in our normal classes, we always explain to people how this works, but we understand not everyone here is in our normal classes. So please select your chat to type to chat relay in the chat thing, and then it will just appear here. And if some people are wondering, how come the message doesn't get through? It's because there's a rule, only one message gets through every second. That's so it doesn't swarm. And which message gets through in the second? Well, it's a bit of a contest. It's the person, it's random, but if you have a higher reputation, you're more random than other people. What that means is that you have more chance of getting in. The reputation has to do with stars. If you happen to make a comment that's like really good or on point, the moderators give you another additional point or something, makes it more likely a message gets through. And if you make a message that's not so productive, unfortunately, they knock off your message and you lose some points. But lose some points in the sense of not being able to talk in the chat. But anyway, just wanted to make sure everyone knows, if you want to participate, you're very welcome. Just type to chat relay. All right.
Awesome.
Wait, Rohan, I like your comment. The larger the problem is, the more simpler its solution. That is so true.
Uh-oh, I'm worried then. Am I going to get a short problem next? We'll
Oh,
see.
no.
All right,
Let's see.
moving on.
Hope not.
Okay, it's medium. Okay, you know what? We'll see. Spread number 18. An eccentric grocery store fruit stacker stacks oranges in a pyramid with 20 layers, so that layer K, the kth layer from the top, is a 2k minus 1, 2k minus 1 square of oranges. What is the difference between the total number of oranges and even numbered layers? Uh-oh. Okay. Let's figure this out.
You got
All
a
right,
hard
well,
one.
right away, let's just write out the first few layers. So layer 1, which is the one, wait. Well, does that mean it starts on layer 0? Because it's the 0th layer from the top is the top
Wait.
layer?
0
Hmm.
to top is 2k minus 1, 2k minus 1 square of oranges. So you have -1 oranges by negative.
Yeah, it should be 1. It should start with
I mean,
1, I think.
Okay. All right. Then, okay. So the first layer, which is the very top. Wait, my bit paper isn't showing up.
I'm guessing that
is-
k starts from 1, only because
Yeah.
2k minus 1 should be positive,
Right.
unless you have an
okay.
anti-orange.
All right. First layer, which is the top. So this is what? A 1 by 1. And then second layer, I'm going to make even. So second layer is well, it's the next odd number. If you notice, 2k minus 1 just says, give me the even number, which is 2k, and take 1 away from it, which makes it an odd number. So these are just going up by odd numbers. So I have 1 by 1, 3 by 3, and just continuing to alternate. I have 5 by 5, 7 by 7, etc. Okay, so now it's asking for what's the difference between the total number of oranges. So we're looking for just the number, which means instead of thinking it individually as layers, let's do how many oranges are in each square. So this is 5 squared, this is 9 squared. This is going to be 7 squared. This is going to be 3 squared. Okay, and we're looking for the difference in all the orange squares added together and all the blue squares added together. Okay. Well, this feels like it's going to be a lot of work. I'm going to hide the problem now.
This is pretty cool though. It's
Oh, wait,
not
actually, I
very
see how this
hard.
can be simplified now. I have a feeling. Okay, I'm going to hide chat as well since it's kind of blocking. All right, so that means what we're doing is this is eventually going to go all the way what? So it has 20 layers. Wait, it's 20 layers? It is 20 layers. Okay, so 20 layers in total, which means that it's going to go to the 20th odd number, which is, it means it's going to go to what, 39? And 39 would be the even layer. So 39 is the 20th layer. Okay, that's off screen. Layer 20 is 39. Wait, did I do that right? Oh wait, that's even. Oops. Hold up. Yeah, I did do that right. Okay, so layer 20 is 39. Layer, which means I'm just, if I'm taking what, I'm gonna scroll this out as well. So all the blue ones summed together is 1 squared plus, wait, no, not 1 squared. 3 squared plus 7 squared plus 11 squared all the way to 29, oops, 39 squared. And I'm subtracting 1 squared plus 5 squared plus what, 9 squared. This is a lot of squares. All the way to 37 squared. Here's the thing, I see squares and I see subtraction. That's a great sign.
Yep.
Instead of adding all of that, sounds like a pain. I don't even know 39 squared off the top of my head. So like, instead of doing the squares, let's do an easier way of calculation. And since I mentioned we see squares and I see a difference, I'm gonna bring up chat just to see if anything's happening. Okay, yeah, something like that. But let's just do it individually. So like just thinking about it per square like this, I don't know if the lines make it confusing or not, but I'm going to do 3 squared minus 1 squared plus 7 squared minus 5 squared, and so on and so forth. And I'm going to hide chat again because it's blocking it a little bit. But since we have difference of squares, let's just do difference of squares. This is going to be 3 plus 1 times 3 minus 1. If you don't know what I'm doing, it's basically a squared minus b squared in general for whatever numbers factors out like so. It's going to look like this. And so if 3 plus 1 times 3 minus 1 plus 7 plus 5 times 7 minus 5 plus so on and so forth all the way to what? 39 squared minus 37 squared. So that's going to be 39 plus 37. That's going a little bit off screen. I guess I'm going to cover my face. Okay, 39 times 37 times 39 minus 37. Okay, wait a minute though. I'm going to bring chat back up. Here's the thing. What do you guys notice about, they're odd numbers, right? So when I subtract them, is there something consistent going on between 3 minus 1, 7 minus 5, 39 minus 37? Yes, perfect. Andrew says the difference is all 2, right? 2. Awesome. Everybody's saying 2. So they're odd numbers, which means the difference between them is just going to be 2. So what this is saying is now we're doing 2 times 3 plus 1 plus 2 times 7 plus 5 plus 2 times, actually, here, I'll just do that. So on and so forth, all the way to 2 times 39 plus 37. Right? And here's the thing.
Yeah.
This is a lot easier to calculate, but wait a minute. I can make this easier to calculate. They all have a bunch of 2's, right? So why not just factor out the 2's? So I'm going to factor out a 2. And now it's going to be what? 3 plus 1 plus 7 plus 5. But wait a minute. This is all the odd numbers. So like, I think it would make more sense for me to list them out as 1 plus 3 plus 5 plus 7, because this is just all the odd numbers. And then this goes all the way to plus 37 plus 39. Which means I'm just adding all the odd numbers up to 39. This is 20 odd numbers. And do you guys know what the sum of odd numbers is? Is there an easier way for me to add the first 20 odd numbers? To give you guys a little hint, I'll keep that up for now. Oops, somebody says n squared. I think they got it. Just observe this. 1 is 1. 1 plus 3, which is 2 odd numbers, is 4. 1 plus 3 plus 5 is 3 odd numbers, which is 9. Oh, somebody said use an arithmetic sequence. That is a great idea. In general, for stuff like this, since it is a common difference, arithmetic sequences absolutely work.
Yeah.
But odd numbers is a special case. And that's what I'm trying to show here. 1 plus 3 plus 5 plus 7 is 16. And if you notice, 1, 4, 9, and 16, what's special about that? Right there, Ivan says they're all squares. These are all squares. And coincidentally, they happen to be 1 squared, 2 squared, 3 squared, 4 squared. And how many odd numbers are, how many odd numbers are there here? 1, 2, 3, 4. 1, 2, 3, 4. So the answer is the sum of the first n odd numbers is just n squared, which means, hold up, I'm running out of space. In here in blue, I have the sum of first 20 odd numbers. I'm sorry, my handwriting is not very legible, but we have this first 20 odd numbers right here, which means all of that is just 20 squared. So the answer is 2 times 20 squared. I'm hoping it's 800. Is that correct?
Yeah, that looks correct.
Okay, awesome.
Yeah. Basically, yeah, the way to do it is just to like look at consecutive layers. Like I even drew it out here because I was bored. Just look at like the first layer and the second layer. One of them is odd and one of them is even. Well, actually the first one's odd and the second one's even. So just look at like the second layer minus the first layer, the fourth layer minus the third layer, etc. And then use difference of squares. You're good.
Awesome.
You have some nice music playing.
Yeah, I don't know what instrument that is, but
Yeah,
awesome.
I think somebody is practicing their music. Please actually do put your thing on mute if you're not. Well, I mean, because you're not presenting, that'd be very helpful. And I accidentally gave host to somebody else, so I don't have the host power on the meeting anymore. So whoever's the host, please help with the muting thing. Well, now, actually, one thing I want to comment about this question also is like, once you see a bunch of these squares that are getting bigger, it actually turns out that if you take successively bigger squares and you subtract consecutive squares, you get linear things. So there's a general philosophy of why you would expect that this is going to be a sum of a normal linear arithmetic progression. It's because actually you're subtracting consecutive squares, but that was just a comment. Okay, I think I'm actually the next one.
I think so too.
Yep.
Okay.
It's your turn.
Oh no, can I actually get any questions right today? Let's find out. What's this? So,
This one looks short, so maybe it'll be hard.
oh yeah, just like the other one, just like the other one I got. I'm trying to figure out my odd, oh yes, my picture does come back. Okay, very good. So quadrilateral ABCD is a geometry problem. So I have side lengths, AB is 1, BC is 2, CD is 4, and DA is 4. Okay, so I've got two things which are of length 4 and two things which are of length 1 and 2. I'm just going to try to draw something which has like a 4, and a 1 and a 2. Let's see what happens. This is not even anywhere close to scale, but let's just see if we can get anywhere here. So, oh, I've diagonal. Oh, I need to give some names. So the CD was 4 and the DA was 4. So I guess I'll try which way? This way? I'm just trying to get a sense of this. AB. Does that look right? AB is 1, BC is 2. Yeah, okay. And then I also have the diagonal length AC is 2. Oh boy, that's not 2. This is like a lot more than 2. Okay. And diagonals AC and BD intersect at point E. So let's put a 2 here. I've got this point E. First, I'm trying to understand what this looks like. And that's point E. And I need to figure out the ratio of BD over BE. So the whole thing over that little bit. Well, first I need to understand what this even looks like. Okay.
This is a very interesting
Yeah,
problem.
this is very interesting. So I need to now look, I got an isosceles triangle. Oh, yes. So whenever I'm trying to draw a picture, I have to be like, do I have anything that I could try to draw this with if I was really trying to build this myself with sticks? And the 4, the 4, and the 2 give me a foundation that I can start with to draw this a little bit more to scale. Let's see if this will work. So I need to have like a 4, and a 2, an isosceles triangle here. This is a 2, this is a 4, and this is a 4. And people are already typing lots of comments about similarity. Maybe that will be what we have to use. But I'm just starting slow, being like, I need to even know what it looks like. Then I have this 2 and 1. Oh, another. That's why you guys are all talking about similarity. Yes, because there's more similarity here. The next one goes with, let's label the 2 inside, because there's another 2 and another 1. Aha. Now this feels very similar, right? I've got a 2, 2, 1, and I have a 4, 4, 2. So in that case, let me make sure I have the things labeled right, because I made some silly mistake the first time, the first problem. They all look like the right lengths. AC is 2. Okay. And then now my interesting thing is what to do here. So I need to know what happens when I go to that point BE. So I have a triangle and I have the triangle turned. Whoa, that is pretty interesting. And I want BD over BE. I'm thinking about this. So I have similarity. Yes, I have similarity. But if I'm trying to figure out what happens to the angle.
There's even more similarity.
There's even more similarity. Well, I want to know, is it actually, I'm curious if that's parallel or not, because my picture shows it's parallel. So I'm now going to use a technique called angle chasing. Angle chasing is where you just mark down angles that are equal and see what happens. So by the way, I haven't seen this problem before. So I'm just showing you how I think about it when I see it. So I'm like, it's isosceles. That means those are equal. But there's also similarity. Oh, so that's also equal. Aha. So there's parallel. Okay, so the thing is that you see how I went through this problem. The first thing I did is I wanted to know what exactly does it look like, because that thing wasn't to scale. So then I tried to draw it to scale drawing. And once I drew it to scale drawing, I said, these two look parallel. I wonder if they really are. But once I look at these angles, you see, now you have this particular angle here is equal to that angle there. So there are these alternate interior angles. That means that my two lengths are parallel. Oh, now I can get the ratio. The reason I can get the ratio is because I have two parallel lines cut by this thing, okay? And in particular, I can mark that this angle here and that angle there are the same because of the fact that it's parallel cut with this line. those are also alternate interior angles. And at this point, I have some similar triangles. I have ABE, ABE, similar to which one? Anyone want to type? Oh, somebody said they're confused. So the important thing here is I drew a picture carefully first. And once I drew a careful picture, I could just go and say isosceles gives me those equal. And then since it's a similar triangles from here to there, also those pair are equal. And I see so many people have said CDE, is it CDE, is it DEC? The order is important when you write similar triangles. So if I have an A, a B, and an E, it has to go from a D and a C and a E. Is that right? Is it DCE? I saw all these different permutations. There's like 6 different possible permutations. But ABE, I think, is similar to
Should be
D.
C.
Oh, no,
CDE,
no, no,
right?
I have it wrong. Yeah, I have it wrong.
CDE.
It's
Okay.
co-host. This is why it's so important to have them here. So
Mhm.
yeah, that's right. It's C. CDE.
Yeah.
Thanks, guys. Okay, so this way, yeah, the order is important. But once I have this, now I can say what the ratio is. The ratio is from 1, it's from 1:4. So, but that's not the answer. We got to be careful. The ratio is 1:4 on these two similar triangles. But the question is not asking that ratio. It's asking BD, the whole thing, divided by BE. So the answer is not 4, but it's 5. It's 5 because it's like 1 plus 4. 1 part plus 4
Yep.
parts. 5 parts divide by 1 part. So I think the answer is this.
Yeah, it should be.
It should be. Let's find out. What's the answer? Yay, I got one question right. Okay, that's right.
And I actually think like angle chasing is really useful in AMC and AE. Like of all the things, angle chasing can probably get you the farthest. Even in like past AME, angle chasing is just one of those things where like it's everywhere. And it's not, it's pretty simple too.
It's a great way to get started on a geometry problem, especially if you're lost and have nowhere to go.
Yeah,
It's a great way to
awesome.
get started, and you'll notice stuff like that. Awesome.
Cool. Let's
Okay.
toss it on to Vivian. I think you're next.
Okay, yeah, it's my turn now. Let's see. Okay, this finally not a huge paragraph. Okay. Is this good or bad? Well, okay, possible arithmetic sequences. Oh, okay, I've seen this type of, wait, I haven't seen this exact question, but I've seen this type of question before. Okay, so like we have an arithmetic sequence that begins with 15 and ends at 51. That's interesting. And by the way, it's an arithmetic sequence, which means that every 2 consecutive terms have the same difference. So it's like you have 15 and then the next term is something like 15 plus x, and then it goes to like 15 plus 2x, so on and so forth until you get to 51. So yeah, each time you add the same integer x. Okay, so we have this. So we're supposed to be calculating the sum of the terms in each of the sequences. Oh, okay. So our first step is to write out or think about all the possible sequences that can be like this. So we want to find all possible sequences that start with 15 and end with 51, and all the terms in between are like apart by the same amount. So I'll just write down like a random one just so you guys can like understand where this is going. So for a random sequence, I guess we could try. So it starts at 15 and it ends at 51. Now we know that every time it'll increase by the same amount. So we have like some number of jumps before we get to 51. And each of the jumps is the same amount. So let's say each of the jumps is by x. Wait, that's a bad place to write x. So yeah, each of the jumps has like length x. And in total, the amount that you go in total is 51 minus 15 equals 36. So this is where I saw you guys were talking about 36. Anthony is like, yeah, the differences is a multiple of 36. Well, I think you meant to say 36 is a multiple of the differences because x, you can see that x is a factor of 36. Yeah, and William says it too, because you have a bunch of x's all multiplied together and they sum to 36. So x is a factor of 36. We know that. And now we just have to see, well, do all factors of 36 work or only some of them? Let's see. So how about we try like x equals 1 or something? Does that work? First of all, x must be factor of 36. So that's important. So let's just like maybe, I don't know, list out some factors of 36. So 36 equals 2 squared times 3 squared, though you don't really have to write that out. I'm just writing it out for like convenience. But if we tried like a random sequence, we could try like 15, 17, 19. Can you guess which value of x I'm using here? I'm using 2 because each time it's increasing by 2. So if I try like increasing by 2, will it ever reach 51? If I continue this sequence, will it ever reach 51? Well, obviously it will, because 51's odd and it covers like all the odd numbers. So yes. So I mean, if you just think about it, it'll make sense that all the different factors of 36 can be values of x. So now we get even further a step. Now we know that all factors of 36 work. So all factors of 36 work. Now, okay, now here's the interesting part. So now we want the sum of the terms in the sequences. So now we'll have to like step back and think about like all the sequences as a whole. Oh, but it doesn't stop there. Now it's asking for the median of the sums. So you want the middle sum. Okay, that's interesting. But first, we'll just look at the sums for a bit. Yeah. So, okay, actually let's look at the sequences. So we have like 15. I'm going back to the x thing because I think it'll be a little bit useful for finding the sum of the terms. So we have 15, 15 plus x, 15 plus 2x, ... 51, which is actually an arithmetic sequence. Does anyone know a way to calculate the sum of the terms in an arithmetic sequence? Oh, A is saying something very interesting. I think you meant to type 51 plus 15 over 2. I wonder why they're saying 51 plus 15 over 2. It's actually because if you have an arithmetic sequence and then 15 is like the smallest number in the sequence and 51 is the largest number in the sequence. So yeah, the median of the terms would be 6. Wait, 6? Are you saying like 6 is a possible value of x, or?
I think he's talking about medians of a different part, which is
Okay,
interesting.
okay.
We might talk about
fine.
it in a moment.
Yeah, I probably just haven't gone there yet, so that's why I don't understand what you're saying. But yeah, thanks for the input. So anyway, 15 plus 51 over 2, which is 33, equals median. And now, like some of you guys are saying, the sum of the terms is just, so sum equals median times number terms. And the reason why this is true is because usually the sum is the average times the number of terms, right? But here, actually, the average is equal to the median because the numbers are just symmetric about the median. So the average must be the median. So the sum would just be 33 times number terms. And guess what? We can actually find the number of terms in terms of x. By the way, we're just trying to get as many things in terms of x as we can. Yeah, William, that's right. So the number of terms, well, we can call this one like this. Well, actually, no, there's an easier way to count them. So here, we could just call this like 15 plus 0x. And this one is 15 plus 1x. And then it goes 15 plus 2x, ... until 51. So the number of terms in this sequence is basically just, well, let's say 51 equals 15 plus nx for some n. Then the number of terms equals n plus 1 because we have the 0th term here, the first term here, the second term here, up to the nth term here. So it's like the number of positive integers, well, not positive, the number of integers from 0 through n, which is n plus 1. So now the number of terms is just n plus 1, but n is annoying because n is not in terms of x. So if only we could get n in terms of x. Well, actually, if 51 is 15 plus nx, then we can do better than this. We can say that 51 minus 15 equals nx, which means that n equals 36 divided by x if you solve for n. So then this entire thing with all the 33 and all that, it becomes, so I think it was down there, it becomes 33 times the number of terms, which is n plus 1, but n is 36 over x, so it's 36, wait, yeah, so it's 36 over x plus 1. So this entire expression right here is the sum of the terms in one sequence, specifically the sequence with a certain value of x. So now we just need to look at all of these expressions and find the median one. So in order to do that, I'm going to just write out the factors of 36, because I wouldn't do this if there were a ton of factors of 36, but there aren't that many factors. So, oh my gosh, okay, I see why people were saying 6 now. Okay, but anyway, I'll get to that later. So the factors of 36, because x is a factor of 36. So we have 1, 2, 3, 4. Let me know if I miss any. 6, 9, 12, 18, 36. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's the correct number. Okay. So yeah, we don't have that much time. So anyway, looking at all the expressions here, I'll scroll up so that you can see that. Looking at all the expressions. So the 1 gives us 33 times 36 divided by 1 plus 1. The 2 gives us 33 times 36 divided by 2 plus 1. So notice that as we go along the line, there's only one part of this expression that changes. And actually, the part that changes is this fraction right here. In particular, if the denominator gets bigger, then what happens to the entire fraction? It gets smaller. Because if you're dividing by more, the entire quantity gets smaller. So basically, as we go down the line, here's like the main punchline of the question. As we go down the line, so as we go on, to abbreviate it, the entire expression gets smaller. Now, the reason why the entire expression gets smaller is because the only part of it that's changing is the part that's circled in yellow, and that part gets smaller. So the entire thing will get smaller. The expression, that's very messy, gets smaller. Okay. So now if we were to find the median, all we have to do is find like the balance point between the biggest and the smallest. Obviously, if x was 1, we get the biggest because it goes smaller. It gets smaller. So at the beginning, it's big. When x is 36, it's the smallest. So if you just look at this entire list, well, which number's in the middle? It's 6, because I don't know, you can just eyeball it and see that it's 6. So I guess this is why people were saying 6. Anyway, to find the median, like to find the actual answer, all you do is plug 6 into this box thing. So all you do is 33 times 36 over 6 plus 1, which turns out to be 33 times 7. Wow, you guys were literally typing 33 times 7 like 10 minutes ago. And finally, I've gotten to it. So yeah, I see where you guys are all coming from. And 231. Oh, I've seen that number many times already. Okay, so I guess it must be right. Yeah, 231.
Yeah.
Anyway, yeah, and by the way, there's like other ways to find out that 6 is the middle number. I think some of you guys were also talking about like 36 being a square, and so you can somehow like pair up the factors like this. So yeah, there's many ways to figure out that 6 is the middle. But once you figure that out, you're done. Yay.
For sure.
That was pretty complicated.
Yeah, I think some of you guys were, I wrote a little bit about just the factors, exactly what Vivian had in the last part. I think what some of you guys did is you guys did this process first, which is how you got the 6 so fast.
Yeah.
But awesome. Do we have time still for another?
Yeah, let's go one. Let's finish the round.
Right.
So you can do one, I'll do one. I do want to make one comment because I saw a lot of people making comments about like, is this being too slow? Actually, the objective of our live stream is to make it so that if somebody is trying to learn math, that they can figure out how to do it. So we're actually intentionally this time not blazing through at the full speed like we did with the AMCA live stream. So actually, we often will explain things slower or maybe with multiple different ways, and that's on purpose. Okay, Eddie, why don't you go and then I'll go and then we'll
a lot of you guys were mentioning like, oh, is there a faster way? If you really think about it, once you figure out that the median is 6, so that the common difference has to be 6, you just have a sequence with from 15 to 51 with common difference 6. And that doesn't really take that long. But obviously when we're explaining it, it feels longer, but it really isn't that bad computation.
Yeah.
But all right, let's clear that. And is this the next problem? I think it is, right?
Yeah.
Yeah. Okay, cool. So Marcus writes out all the subsets. Okay, subset of a set is just like a portion of it. So just taking 1, 2, 3 or something. Okay, all subsets of the set 1, 2, 3, 4, 5 all the way to 10 that have more than one element. Jean then writes down the sum of the elements in each subset to the nearest integer. What is the average of the sums Jean calculated?
Oh my gosh, average of sums, and mine is about median of sums.
Oh no. Okay, well, it's talking about average of sums. So I'm thinking about this. Since we're writing the sum of every element, it doesn't really matter what each subset is. It only matters how many times I'm counting every number, if that makes sense. So like, for example, let's take the number 1. 1 can be in a subset 1, 2, 1, 3, 1, 4, 1, 5, etc. Or it could be like 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 2, 6. But I don't care about any of that. I only care about how many subsets is 1 in. So let's think about how we would calculate that. Well, what I can do right now is, wait, am I making this too complicated? A lot of you guys are getting, okay. Well, what I'm thinking is, once I take 1 out and every other number, there's 2, 3, 4, 5, 6, 7, 8, right? And then, sorry, not 8, all the way to 10, 9, 10. And then how many subsets are there can I make from this? Since we're running a bit low on time, the spoiler I'll make is that the amount of subsets I could pull from this is exactly 2 to the number of terms there are. In this case, there are 9 terms. But that includes the empty. So what I'm basically doing right now is I want to add this subset to 1. So for example, if I take a subset 3, 4, I'm going to add that to 1 to make a subset 1, 3, 4. And then, for example, no matter what subset it is, I'll just take that and add it to 1. So I'll have 2 to the 9th subsets from here, but that includes an empty subset where I have nothing in it. So there's actually 2 to the 9th minus 1 subsets that I can make with 1. So that means 1 is in 511 subsets. 1 is in 511 subsets. And using similar reasoning, 2 is in 511 subsets. 3 is in 511 subsets, all the way to 10. Which means I'm adding 1 times 511 plus 2 times 511 all the way, hold up, let's read what chat's going on. Chat is saying, taking the average of the sum of the subsets. Oh yeah, all the numbers are counted the same amount. Exactly, perfect. So that's exactly what we're covering right now. All the way to 10 times 511, it's a little, all right. All the way to 10 plus 511 over how many total subsets are there? Well, wait, actually, the average of all the sums. Okay, yeah, so it is, we're dividing by the total number of subsets.
Yeah, you're good.
So that's what? 2 through 10 is every subset I can make using 10 numbers. Uh-oh, it's a little not visible. I'll use white. 2 to the 10. But I don't want the subset that has 0 terms, which is the empty subset. That's minus 1. And I don't want the subsets that have exactly 1 element, because that's not more than 1 element. So I have to subtract out 10, because there's 10 subsets with just 1 element, which is just 1, 2, 3, 4, all the way to 10. So this gives me 1000, wait, 1012? No, 1013. Yes? Yeah, okay. So it's 1013 subsets, which means the answer is going to be this huge sum over 1023. Why does this feel?
1013.
Yeah, sorry, I forgot to calculate it. Thank you. So how would I sum this? 511, pulling that factor out from the numerator. Actually, I don't need the problem anymore. Pulling that out from the numerator multiplied by 1 plus 2 plus all the way to 10. Well, this is just the sum of the first 10 numbers, which means this is equal to n times n plus 1 over 2 using the formula, but n is 10. So there's 10 times 11 over 2, all of that over 1013. This feels like it's going to be really messy. Is there a way I can simplify this? Well, I don't know. I can cross
round to the nearest integer. That might help you.
Oh, oops. Okay, well, that helps. Well, right away, let's think about this. So 511 is roughly half of 1013. Not exactly, but like close enough, right? So it's honestly close enough that I'm just going to estimate it as 1/2. So this is approximately 1/2 times 10 times 11 over 2, but I just made the cancellation that 10 divided by 2 is 5. So it's roughly half of 5 times 11. Okay, we're in a little bit of a dilemma here because this turns out to be 55 over 2, which is equal to what? 27.5. Uh-oh, do I round up or round down? Well, let's think about this. What assumption did I make to estimate 1/2? Here, let's bring chat back up. Eliminate round to 28. So somebody is saying round up to 28. Well, let's think. Is 511? Yeah, okay. Andrew says it's greater than 1/2 because 511 over 1013 is actually greater than 1/2. If it was actually 1/2, it'd be 511 over 1022. And 511 over 1022, that's 1/2. So since I have a smaller denominator, 511 over 1022 is bigger than 1/2. So this is bigger than 27.5, which means we're safe to round it to 28. Awesome. Really good job, guys, chat. And thanks for the catches. That would have been a huge chore if I didn't see the round to the nearest integer. Read the problem, guys.
Yeah, this was good. This was good. Vivian, did you want to say something? You seem to have stuff on your screen.
Wait, okay. I have not like completely figured out this solution yet, but like I was just thinking about of every sum, like we're looking for the average over all the sums, and each sum is actually equal to the number of numbers in the sum times their average. And well, I was thinking about how to find the average of each of these separate components and then multiply them together, because that should be basically the answer, right? So I first did this part because it was easier. Like the average of the numbers that are being summed is like, I think it's 11 over 2 because that's just the average of all the numbers in the set. And all of them are like, they have identical chance of being chosen. So I thought this was 11 over 2. And then, but the first part was a bit harder because I needed to find the average number of numbers included in the sum. And I kind of used the same logic as Eddie used. Well, I thought that like you could have 2 numbers picked, 3 numbers picked, 4 numbers picked, up to 10 numbers picked, and like their average is about 5. It's a bit more, but it's about 5, especially because the number of ways to pick 2 is 10 choose 2, and then we have 10 choose 3 up to 10 choose 10. And if you know about like the symmetry in Pascal's triangle, it's like about symmetric. So the average should be about 5 numbers included, but it's a bit more than that. So I basically got the same thing as Eddie, like 5 times 11 over 2, but then you round off.
Yeah, I think that's right. So I mean, actually, what Vivian just did is more tidy than what I was doing. But what I was doing was I was just saying the average of this thing is the average of the contribution that 1 makes, plus the average of the contribution that 2 makes, plus the average of the contribution that 3 makes, and so on. And each one is on average in half of the sets. Except that it's a little bit more than half of the sets because we're only picking the sets that have more than 1 element. If we picked any subset period, that's like dividing by 1024. If you picked any subset at all, then the fraction of time that a number gets picked is exactly half. And now, since we're biasing it so that you're more likely to pick the not empty sets, you're going to be slightly more than half likely to pick the element, which is exactly how you get to what Vivian was doing.
Yeah, and by the way, this like slightly more likely thing only works because the number of subsets that you aren't allowed to pick is very small. Like the number of subsets you're not allowed to pick is the ones with less than 2 elements, which are only like 11 subsets. So it only works because 11 is such a small fraction of 1024 that we can kind of like hand wave all of this.
Yes, that's really important. Okay, let's do. Oh, Eddie, did you want to add one more thing or no?
No. I think that was great. I that's a lot faster. And adding on to what we said about when we do estimations like that, just make sure the number is really big so there's not a huge error. And yeah, that's it. Really great comments. Awesome.
Okay, I guess I do one more question. What is this? I got an essay.
Well, essays are easy, so you're in luck.
Right.
We'll see.
That's what we learned today.
Okay. Because we're actually over time, but I'll just do you one question anyway. Let's just see. So there's somebody has already warned. This is a very tiring question. Let's see. Two particles, A and B, are initially both at the number 100 on the number line, and the wall is located at the number 0. Note that 0 is to the left of 100 on the number line. Yes, it is. Particle A moves 2 units per second, while particle B moves 1 unit per second. I need a picture. I'm losing track of the problem. So I have this thing. I have a wall. The wall is at 0, and there's this 100. And we've got the A and the B. A is moving fast, twice as fast as B is. Okay, this is just, I'm drawing this so I can keep track a little bit as I'm reading the question. Both particles begin by moving to the left. Each time particle A collides with the wall at the number 0, or collides with particle B, not including the start, particle A changes direction while keeping the same speed. Oh, the particles continue moving until particle B reaches the number 0. For how many seconds is particle A traveling to the left?
This looks so hard.
So this is going to be some kind of a geometric series, actually. Because so at first I was like, oh, can I use this fun trick, which is like particle B is going to move 1 unit per second for 100 units. So particle B is moving for 100 seconds. Okay, so particle A, is it actually geometric series? It should be. And particle A is going to be moving for a total of 100 seconds. Oh, I have a way to do this. Okay, I was going to say, I thought we were going to have to add a geometric series. No, let me write down a few things, okay? So I don't have to do a geometric series. So here's the wall. Here's 100, okay? Particle A is the speedy one, moving at 2 units per second. Particle B is the slowpoke, moving at 1 unit per second, okay? So now here's the deal. How long is particle B moving? Can anyone type in the chat? Like, just because of the fact that it's squeezing like a snowplow. It was snowing around here in Pittsburgh, so I say snow. How long does B move? Well, just 100 seconds, because it takes 100 seconds to squash A down there. Okay, in that case, how far does so let's see. A is now buzzing around. A is just like going do. And if I only care about the distance, the absolute value distance that A moves, absolute value means no matter which way A is going, I'll count it as distance. A is using up gas, let's pretend. So I'm like, what's the total distance that A covers? It will be exactly 200, because of the fact that A is moving for 100 seconds and A is moving at the speed of 2 units per second. Okay. So what that means is that the total distance back and forth A moves is equal to 200 units. Okay, but if A moves 200 units total, it has to have a net movement of 100 to the left, right? So you can actually tell how much of A's movement was moving to the right. Right. How much of it was moving to the right and how much was moving to the left? Does that make sense? What I'm trying to say is that if A's total left plus right, like the total left plus the total right is 200, but the total left minus the total right is 100, there's a gap of 100 between these two. Okay. So now I know that A's total left plus total right is equal to 200, and the difference, the total left minus the total right, is equal to 100. The reason I'm doing this is because there was a question which was asking how many seconds is A moving towards the left? So if I want to know how many seconds A is moving towards the left, if I can find the total distance A was moving to the left, I can divide by A's speed of 2 and I'll be done. Okay, and we'll find out soon. There'll be a 1/3 in here, I think. So I have these two things. It's time for some variables. Let's call it L and R. Okay, so I have L plus R is 200, L minus R is 100. And my question is, what is L? How many seconds are going to the left? L is the distance, the total distance going to the left. Total distance moving left is equal to help. What is this? So I have two numbers that add to 200 and the difference is 100. Oh, some people already said it's like 150 and 50. Okay, so it's 150. But you can also see this by doing the usual way you solve equations. You can take this guy minus this guy, and this guy minus this guy will give you two L's. No, it won't. I want L, so I add them. So I get two L's is 300. Half of that L is 150. Okay, well, in that case, now I will just divide by 2 to find the total. Wait, why is there a 1/3? Now I'm curious. People were saying there was a 1/3 here. Now I'm scared because maybe I'm wrong again. So let's see. So the total time moving left is going to be 150 divided by your speed. The speed was 2. I'm getting 75. There's no 1/3 here. How many seconds is A traveling to the left? Does that even make sense? Let me see. So I'm not rechecking my thing because maybe I'm wrong. So let's see. I might be wrong. I was expecting a 1/3 to pop up. So let's see. So I'm just double checking again. Does this logic make sense? So I have B moving 100 seconds total. Yeah, squishing A. So A is going to move 200 units, of which the total left plus the total right is the 200. And the difference between them, wait, is it that the left minus the right is 100? Yeah, it is. Yeah, it is. I wonder if that means I'm right. So we'll see. So meanwhile, what I'm going to do is I just did the way, and let's keep the lines open. Do any of the TAs have another way? Maybe where you added a geometric series?
Yeah, I got 75 with a geometric series, so I think it's right.
Why don't you tell us?
Yeah, I did that way.
Okay,
as well.
my way is really complicated though. Your way is so much more slick.
You were done before me.
Wait, no, not really.
Okay.
I also kind of hand waved a lot of it.
Why don't you quickly go over it and then we'll check the answer.
So just like really generally, I just drew like a few diagrams. So like this is so the top one over here is at t equals 0 or time 0. They're both over here on the right. And then I drew another diagram for after 50 seconds, which is this one. And A has like reached the left, but B is halfway in the middle. And then I drew another diagram for the first time they meet. That's not like the very beginning, which is after 200 over 3 seconds. And they meet like right here, which is like 2/3 of the way to the left. And then I drew another diagram for t equals 250 over 3 seconds, which is when A reaches the left side for the second time. And then I started to add up the times in which A was traveling to the left. So the first time I counted was between t equals 0 and t equals 50, because A was traveling to the left between those two time captures. So I got 50, and then I also added the time between these two because A was also traveling to the left between those two. So I got 50 plus 50 over 3. And then this is the point where like you could write it all out if you wanted to, but I kind of assumed, just because like I've done these problems enough times to like know that there has to be a geometric series sometime. So if you kept drawing this out, you'd find that like the next time they would meet somewhere over here. Let me draw it. They would meet somewhere like here, and the amount of time it would take for A to get back to the left side after that time, you would just divide by 3 again and get 50 over 9. Like the reason why that's true, it's kind of just the same reason that this is true. Like, how do I explain this? Yeah, because basically in this diagram, you see how the point B is like 1/6. Well, actually no, let's say it's 5/6 of the way to the left side. And then in this diagram, which one? Yeah, this one, it's 1/2. Wait, no, it's 1/2 of the way there. So basically from this diagram to this diagram, the amount that I'm like highlighting in yellow segment like multiplies by a factor of 1/3. So the same thing happens with the next two diagrams that you would draw, except everything is shrunk by a factor of 1/3. So anyway, that's the general gist of it. You get this infinite series, and then you sum this up with the usual infinite series way, which like, yeah, I don't know if I should explain that right now, but Yeah, that's like the geometric series, but maybe Eddie has something to add.
No, I basically did it the exact same
Yeah.
way. So I think you covered everything. Awesome.
Wow. But is it right?
Yeah, I
Is
believe the
it?
answer is
That's
75.
right. Oh my God,
Yeah.
it worked.
Your way is really cool.
Oh yeah,
I didn't think of that. Wow.
was just surprised it would work. I mean, because I'll tell you, because I'm lazy. And actually, there's this, maybe I'll close with this funny story. There was this funny story that, the classic problem with this is you got two trains which are running towards each other and going to crash. And there's a bee going in between, going back and forth.
Yeah, that one.
A very sad story. But the thing is that it's basically you study like how long does it take, how long is the bee flying? And the funny story is that there was this famous mathematician named von Neumann. He's brilliant, absolutely brilliant. Hungarian guy, I think. And so the deal was that at some point somebody asked him this question and he instantly answered it as if he knew how to do it. And then someone said, oh wow, yeah, it's that usual thing, right? You just find out how long the bee goes. And he said, no, I just like calculated the geometric series and added it all up in my head. So basically, depending on how fast you can see them, you're good. Okay, with that, actually, I'm going to say, I hope you guys had some fun. We had some fun. These are good questions. If you like these questions, we actually do recommend you go and register for Math League. They're going to have, I think, 2 more of these qualifying rounds. So we're going to do this 2 more times as well. Oh, wait, was that actually legit the last thing? No, it wasn't. Because I saw Andy has bounced to the end. Right.
I have.
Yeah. Actually, if people enjoyed this particular meeting, you're also welcome to follow us on the various social media and so on. Let me just move this chat out to here. But I will also make a comment about Math League, which is that these problems are pretty darn good. So if you like these, go ahead and try them. Join the Math League and you'll be good. Actually, we'll be doing more of these live streams. There's actually another bonanza that we're going to do. It's at the end of February. It's the Math Counts chapter review. We're going to do it the same way. The new way that I like to do these live streams is not to do them solo, because as you can see, I make tons of mistakes. We need to have other people who are actually sharp and who can also help provide other insights. So we're going to do a next one of these live streams. It's on Math Counts at the end of February. And then at the beginning of March, we'll do the next round for the Math League. But with that, I'm just going to say good luck to everybody, no matter what you're doing in mathematics. Hopefully this was somewhat entertaining for you too. And I guess we'll call it a night, although that just means officially it's over. Sometimes people randomly hang around for a little while, but
yeah.
Thank you, everybody.
Yeah,
Thank you.
Great to see that you guys learned a lot.
Yeah.
Bye-bye.
Yeah, bye everyone. Thank you.